Hello. This video is designed to show you an example of how to work through calculating values for a parallel circuit. This worksheet is available right next to this video link, so you can download it and work with me, or you can watch and work on it later. It's basically just a blank parallel circuit and a blank table. So before we get started, we just need to quickly review our two formulas that we're going to be using. V is equal to I times R, and P is equal to V times I. V is voltage in volts. I is current in amps. R is resistance in ohms. And P is power in watts. Okay? So by now you should be familiar with these symbols and their units. If you're not, you need to spend some time practicing them because those will help you out a lot, especially when you get word problems. Alright, let's talk about what happens to charges in a parallel circuit. So if you have, so the charges here, we're going to pretend we're following a charge that was near the battery and then it's moving through the circuit. So here the charges are all together as they move along, and then they get to this branch point. Here some of the charges are going to turn and follow this branch, and others of the charges are going to keep going. So your current actually splits here. It may split equally, it may not split equally. It depends on the resistances of your components. If let's say this one, which I can change 2 and 1. If this one has a very, very large resistance, not many charges are going to keep going. If this one has a bigger resistance, more charges will keep going. So it just depends. Charges are lazy and they want to take the easy way out. Okay? The charges that are left over, once they get to this branch point, some will go through and some will keep going all the way around. When they get back to this branch point, on the other side, they'll pick them up. They'll move on together, they'll pick these guys up, and they'll continue on back. So in a parallel circuit, we say that current is additive. That means that the flow rate of charge in branch 1 is added to the flow rate of charge of branch 2, added to the flow rate of charge of branch 3 is the total flow rate of charge. Basically, they start together, that's where you have the total, then they split up, but they come back together. So these have to equal what they started out with when you add them up. I'm going to skip resistance because it's a little bit scary. So voltage is constant. Okay, so now when we say constant, we don't mean that it's the same at all points around the circuit. We mean that the amount of energy that we lose in the first branch is equal to the amount of energy that we lose in the second branch, which is equal to the amount of energy that we lose in the third branch. The voltage across each of these resistors has to be the same. We know that voltage is made up of current and resistance. Okay, so if one has a higher resistance, it's going to get less current, which is going to allow the voltage to be constant. If one has a lower resistance, it's going to have more current, which is going to allow the voltage to stay the same. So that's why we say that. Because when we add branches in a parallel circuit, we're actually able to decrease the overall resistance because now charges have more options. It's kind of like going from 1 lane on a highway to having 3 lanes on a highway. It's a lot harder to make it through that 1 lane with the same amount of cars than it is if you have 3. So we call resistance inverse additive. And it sounds scary, and the equation looks kind of scary. So 1 over RT, or it's total resistance or equivalent resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay? And I'll show you how we can practice using that in just a second with some made-up numbers. Again, the main idea to remember is that as you add branches, the total resistance is going to decrease because the charges have more paths to follow. Okay, so let's make up some numbers again. Let's say I have a total voltage of I don't know, let's say 30 volts for fun. So I'm going to put that here in my total column. And let's say this light bulb is 5 ohms, this light bulb is 10 ohms, and this light bulb is 15 ohms. Okay, so I'm going to put those under resistance according to their number. So 5, 10, 15. Now when we did a series circuit, we could just add all of those up and get our total resistance and move on. Here, if we wanted to find our total resistance at this point, we would have to use this formula, which can be a little tricky. So I have another way to do it that helps me, so I'm going to share that with you. We know that because it's a parallel circuit, our voltage is constant. So we can put, if we have 30 volts here, we're going to lose 30 volts across this resistor, across this one, and across this one. So we can put 30 in each of these boxes. Okay? So we know that. We also know that voltage is equal to current times resistance. So using our formula, if we need to solve for current, we'd have to divide both sides by resistance. So V divided by R gives us current. So for resistor 1, our voltage of 30 divided by our resistance of 5 would give us 6 amps in resistor 1. For resistor 2, 30 divided by 10 would give us 3. For resistor 3, 30 divided by 15 would give us 2 amps. Now, we know that current is additive. We know that the current going through 1 plus the current going through 2 plus the current going through 3 has to add up to equal the total current. So we can add these together. So 6 plus 3 is 9 plus 2 is 11 amps. Okay? Now we can find our total resistance by dividing both sides of Ohm's law formula by current. So 30 divided by 11 would give us 2.23 ohms total resistance. You can check that with your fractions if you'd like to. The way that you do that is to take, you want to know 1 over the total is equal to 1 over, the first resistance is 5, plus 1 over 10, the second resistance, plus 1 over 15, the third resistance. Okay, now you can find lowest common denominator if you want to, or you can just put those into your calculator. So 1 over RT is equal to 1 over 5, which is 0.2, plus 1 over 10, which is 0.1, plus 1 divided by 15, which gives us 0.066 repeating. So then you just add those up, and it's 1 over RT is equal to 0.36. I'm going to round it to 7 there. And a lot of people will just stay there with their answer, but you need to remember that it's 1 over RT, that is not equal to RT. So if you put both of them to the power of -1, it'll give you RT, and it will be 2.72, which is what this one should have been. Sorry, 7.3. Got a little backwards on my numbers there. So that's how you can check yourself. See, I just had to do it. All right. The last thing we do is power. Of course, remember power is equal to voltage times current. So 30 times 6 is 180 watts. 30 times 3 is 90 watts. And 30 times 2 is 60 watts. So again, we see that the, well, in this case, the one that would be the brightest is the first one because it has more current going through it, and the second one would be dimmer, and the third one would be the dimmest. Just because fewer charges, if they had the choice, would go through a higher resistance path. More of them are going to take the low resistance path. But again, we see that power will indicate brightness. If we wanted to calculate the total, it would be 330 volts. Okay, I hope this has been helpful. If you still have questions, feel free to ask your teacher. Feel free to come up with your own problems. Just make up some numbers. If you're worried that you didn't do it properly, you can always ask. But there's always the check of, does this number equal the number you got with the fractions? Again, hope it's been helpful. Have a great day.